Hello, everyone.
Hi guys, welcome back.
Yes. Uh, as you remembered last session, we were working on the repositories. We were refactoring the code, and we are trying to write dedicated repositories for each entity inside the application as a gateway for saving and restoring the data. But before completing that, I want to switch the gears a bit here and talk about some other subject that we will be facing, and then later we can come back and complete the work that we were doing before and working on the repositories and refactoring and all that stuff. Refactoring is a process, is an ongoing process, is not a process that okay, it is done and then we leave it. It is an ongoing process. You should refactor anytime. So I want to talk about this customer app, this another application which connects to our shop manager. So up until now, we have an application which is suitable only for a single user, for the manager of the shop. That the manager of the shop will change the shop name, will create product, will create customer, will be able to create shopping cart, and all these features. But for example, and in order to use this software, to use this application, all the customers should come to the shop by themselves physically and buy the stuff they want, and the shop manager will use this application to book the things, the prices, the purchases, everything for himself. But for example, the shop manager, all the shops, for example, have something like phone service that the customers call the shop from their home, and they order their stuff, and someone, for example, picks the stuff from the shop and brings it to their place. And we want to, and you see all these customer applications, for example, Amazon or Alibaba or eBay, yes. That you have an application that you see all this stuff inside a specific shop or in a bigger, for example, Amazon shop, which is distributed everywhere. You place your order and they bring it to you. And we want to do that here. We want to move, forward, to some kind of a client customer app, which connects to this application that the shop manager is using, and the shop manager, instead of answering calls and getting orders on paper, will see the orders inside the application and will fulfill the orders inside this application. And it is a pretty much usual scenario in e-commerce applications. You have the manager application, the customer application, multiple applications that connect to each other. For example, it is connected to the inventory and all that stuff, and form the whole application. So the first thing that we want to cover here is what is needed because for writing a customer application, we are writing another separate application which will run somewhere else, and which will connect to this one, which will connect to this manager application, shop manager application.
Somehow you mean the server?
Yes. So at some point, one of the applications will act as server, the other will act as client, and we want to talk in this session. We want to talk how is this possible for two applications to talk to each other. So let me just run it once here. The application that we had. Okay, now it's running, waiting for us to enter something. Now, no matter what your operating system is, let me show all the processes inside. These are all the processes running inside my machine currently. It's an Ubuntu operating system, and it doesn't matter if it is Android or if it is iOS or Mac OS or most of them are Linux based, or if it is Windows, in the task manager, you can see all the processes that are running. So this application is running, and I can show it to you that this is the one. This is the one that is running currently. And if I kill it, you'll see that my application will stop. And it is stopped here. You can see that. The application was stopped. So, or for example, you open this Google Chrome browser or any of these softwares, the IntelliJ IDEA itself, you can see here, inside here, that each of them, for example, Chrome, has many processes running currently. So each program that you run for example, in your Android device or in your iOS, on your iPhone, when you open application, it creates a process and it tries to run that app, the code that you've written that has been compiled, it tries to run that inside that process. So we are going to run a process, shop manager process in some machine. And for example, we are going to write an Android application in some other machine, in an Android device. And that application will be running as a separate process. So if you wanted to write the customer application inside here, which we are doing it right now, this is a single user application. Only a single user can use this application, because we want to be able to use it by multiple users simultaneously. We want to run separate processes in separate machines, one in my device, one, for example, in my friend's device, which connects to this one. So we want to talk about the ways that is possible for two processes to connect to each other and pass data to each other. And so let me show you this post in the Wikipedia. In the Wikipedia, we have this post about the sorry, this is not the one. Let me write it. Okay, this is the one that I want to show you. So in order for two processes to connect to each other and pass data, in the operating system, we call this interprocess communication, IPC. It stands for IPC, interprocess communication. So let me show you the approaches that we have for interprocess communication. So in this column here, it is indicating that based on the operating system that you have, you can use these methods in this left column here. So for example, it has been written here with most operating system, you can share data between two processes with the file. Of course, you can share with two processes running inside the same machine. They are, of course, sharing the disks and hard drives inside your machine, and they can agree on some kind of file and share data. For example, one process can write to it, another process can read from it. Or for example, the message queues, the anonymous pipes, named pipes. If you read through them, most of them are only possible for two processes inside the same machine. For example, the shared memory inside the RAM. Multiple processes are given access to the same block of memory, which created a shared buffer. For example, one of them write to the memory, another one, and the operating system notifies the other process about the data that has been come. If you read, most of them, maybe all of them, except one, are only possible for two processes inside the same machine. But what if we want to run one process inside this Ubuntu machine as shop manager, and one inside, for example, my
in a device,
Android, or one inside a Windows machine as shop manager, which is completely other, different operating system, and one in an Android device, which is a Linux-based system, which are far away from each other. So the only one here, because I read it once, I believe the only one here that makes it possible is the socket. So the socket is built on top of the network interface, is the interface for doing networking stuff, and you use these sockets for everywhere. Your applications are connecting to their servers, their backends. You are downloading files, you're uploading files, you're checking Instagram. Everything you are doing is through a socket connection. So the socket is basically like connecting a process to another process through the internet, through the stack of the internet, the infrastructure that we have. And the operating system will actually make it possible for two processes to connect to each other. And for example, from one process, you will address another process. For example, you will contact the process with its address, and it will go and directly connect to that process, no matter the operating system. Maybe you are trying to connect from Windows to some other process currently running in other machine, far away, maybe in the same machine, no matter. It is possible. And I don't know if you know anything about networking, and this is not a session about doing networks and all that stuff. Just I wanted to show you that in order to pass data between two processes, we have to use one of these methods, inter-process communication methods. And the only one that makes it possible for two processes far away from each other and operating system agnostic, no operating system dedicated specific thing here, is just socket. And we are going to I'm going to create a socket here in this session just to show you how two processes can connect. So let me just real quick here create another file just for this purpose, just to test. So let's say socket test, and I'm going to create a main function here. And so in all of the application programming languages, because the socket has been developed in the operating system itself, and all the programming languages are using the services written in the operating system. They connect, for example, when you are writing or reading to file, actually you are connecting to the files to the services that have been written for you in the operating system, and you are asking them to do the job. And also when you are trying to open a socket connection to other process, you are actually asking the operating system. And it is possible from any language that you use, any programming language, C, C#, Python, I don't know, PHP, anything that you use can create a socket connection, ask the operating system. So in order, in the Java, because we are using Kotlin, it is actually using the JDK. And in the JDK, for creating a socket, one should be as a server socket, another one should be as a client socket. So say I want to wait here, I'm going to create a server socket. Vals server equals server socket. And now I've created a server socket, but for server, we are running in this machine which has some IP address in the network that we've been connected to the router that we have. But I must also, maybe in this operating system we have, as I showed you, let me show you again. We have all these processes here, and maybe one of them are opening multiple socket connections, other one 2 socket connections, and we have multiple connections for each of them, and some data is coming from outside and wants to, for example, go through one of these processes. So the question here is how the operating system will know which process to give the data to. The question is this, and that the answer is the port. So each connection is specified with a port number, is an integer number with a port number. And when you want to connect, when you want to listen to incoming connections, you should specify which port you are going to listen. And the client should specify and not only the address of the process, not only the address of the machine that is running the process, but also the port of the process inside the machine that is running currently. So for example, let's say I'm going to 1234 on port 1234, and then I want to say server dot accept. When I say server accept, we are actually using the API that have been written for us. So when we call the accept on the server socket, it will stop here. It will stop in this line, forever. We can specify timeout, of course, but it will stop here forever, waiting for some
Port number.
process connecting through this port number to this process. So after someone connected to this, then it will return a socket.
Waiting for a process or a port number?
No, waiting for the process. We acquired, we just grabbed the port here, 1234.
We are waiting for this port number.
No, we are waiting on this port.
Now we are this port, actually.
For example, you
this
can...
is the name of our port.
You can consider this as a building,
So server that accept, wait for this port or no?
No. Server that accept, we have acquired this port. We are now blocking here, waiting for... Yes, we have grabbed.
This port.
Now we have this port, yes.
It means that this is the gate that is the name of our port, actually. The gate that the other ports...
when some process in the machine asks for a port from the operating system will, for example, check if any other process has taken that port, and if it's the case, it will throw exception. But if it has not been taken, it will give you that port. It will be yours.
We can say this is the name of us.
No, it is the address inside the machine. 1234. It is not name.
That's unique for us.
That is unique for us in this machine.
Name means that as we can call it as a name or no.
Yes.
For example, that is the name we have. This is the...
Yeah, some sort of. Yes. If you
and
want
then
to see.
after that?
And then in the second line here, we are... Just let me run this. Nothing will happen. We will grab it.
Okay, up to here, there is a door. As you
yes,
said, maybe.
Yes,
the name of the title of that is 1, 2, 3, 4, 5.
Yes, you can see something like that. We have taken a door and we have not opened it, and now we are going to open it, wait for someone to come, but we will wait forever.
That's not important who.
No. Just someone coming to this address, to this door, to this port. And of course the door was a good analogy, because the addresses here are the buildings. We have a lot of buildings, and each building is specified with the postal code. But for example, maybe inside a building you have multiple houses, multiple homes, and they are dedicated with the bells in bell numbers. For example, the floor number 1, 2, 3, 4, and we are addressing the two processes to two machines with their IP address, and also the each floor, each house, each home with their port numbers. Floor 1, floor 2, floor 3, something like that. And here we have opened the door of the house, and we are waiting for someone to connect. And if I run it,
it is not important who.
If I run it, you will see that it won't stop. The application is running here. We have also a process here. Let me show you which one. Yes, this is the socket. This is the one. The PID of 11. Each process is being given a ID. And this is an Ubuntu. If I run this, let me see. If I run this, I've written it here for checking the processes that I don't see it. Yes, that's the one. IOIS LSOF-I this. So you can see here that this process 11014 is listening on port 1234. This process, and if I don't give this, you will see all the processes that are listening. For example, this process is listening on port 555. This process is listening on 8554. We have a lot of ports opened by multiple processes, and one of them is for us. This is our application running and listening, sitting there listening for an incoming connection. And this time I want to write the connection, and I want to make it a little bit fun. I've written it actually before. I want to write the connect client, the connector in an Android, in a simple Android application, in order just to prove that two separate machines are connecting to each other. So this is an emulator here. This is an Android emulator. I don't want to teach anything about Android here. I just want to show you real quick that we have written some Android application that is this is a separate machine. Of course, this is an emulator, and we can test it on a real device, of course. But I wanted you to show to see both machines in the same screen. So I've written this. Let me show you this application. I want to this is an Android application here. It's just a simple one, a real simple one. And if and we have everything is red. It will be okay soon, I believe. Let me try to run it. I should build it first. So while it is being built, let me just explain things here a bit. But I don't expect you guys to know anything about Android here. We have defined a simple screen, a simple application with a single screen that has a text field and a button. So just let me just explain the things here just real quick. And I don't expect you guys to know anything about Android application stuff, writing, anything. And it has been written in Kotlin language that we are actually learning here. But let me explain things here. We have here a single application with a single screen, which has a text field and a button. So anytime that the button is going to be pressed, I want to take the content inside the text field and send it to the process running here,
which is waiting
for something to be written. So here I should first come here and I should first write socket dot get input stream. I should grab the input connection coming for data, and I want to read all the bytes, and then I want to put the bytes, because with socket you can only pass byte data. You cannot pass strings, and all the data, integers, numbers are bytes, are a sequence of bytes after all. All the data that we have are byte, but we have, before sending, we have to serialize, and after receiving we have to deserialize. So now that we have read all the bytes, incoming bytes, we want to deserialize it into some kind of string. We want to interpret it as a string. So if I create a string and pass the byte array, it will create a string based on that. And then I want to actually print the string here. And then I close the socket. Just simple. 4 lines of code. I run it again. I just want to run this again. Again, it is waiting for us. Nothing is happening. We come here. When we click on this button, when we click on the button that we have, I want to grab the text inside the text field. Just pay attention to this part. I've created a socket here. It was a server socket, but this time here we have a socket. But not only we should address the port 1, 2, 3, 4, we should also address the building address. This is the IP. We address 2 machines based on their IP on the network. And because my machine here has this IP, and this device is connecting through socket to this machine, is connected to the same machine, is on the same network, so it can access this with this IP. So I'm giving the IP of my Ubuntu from Android, and also I'm giving the port address. And then this time, after the connections has been made, it will wait here until, or it will throw exception. It will wait until the connection is made. It will look for this address, for the port running on this address, for a process that is listening on this port in this address, in the machine in this address. And if it sees something, some process, it will connect to that. Then it will come to this line. Then we will get the output stream, and we will try to write the bytes inside the text field. And then we close the socket. So I have, let me minimize this. I have run this here. This is the application. This is the text field. And this is the button here. So for example, let's say I write mass OD. And I want, if I click this button, I expect to see it here. So let's check it. You can see that the text here is coming to this process, you know. So I'm able here, it makes me able to pass data between two processes. One of them is acting as the server, other one is acting as the client. You know, at some point they can switch the roles. Maybe at some point the Android application can open a server socket in a port inside. For example, in your phone, you have a lot of processes that are listening on some ports for incoming notifications. Instagram is notifying you, you know, back and forth. And it is because that your application has been opened, some ports waiting for notifications coming from the Instagram. And if, let's make it some more fun. Let me just put these lines, these 3 lines inside the while loop. While true, stop here, block until someone connects, get everything that the socket is trying to send us, print it, and then close. If I run it again, just wait it for this process. Okay, it is running here. If I click, you will see that it is acting like a chat application, you know, but it is a unidirectional. It's just the Android application can send message to this one. We can make it bi-directional. We can write something, you know, we can read line here from the console and send the data to that process to make it a real chat application. But that's not the purpose here. I just wanted to show you in this session. I just wanted to talk. I know this is a lot, you know, this is a lot to grasp here. This is the networking, you know, with socket API and interprocess communication and everything. But the more we advance, you'll see that you'll get more fluent with these stuff. And this is the only way for two processes, no matter the programming language, no matter the framework that you're using. If you are using an iOS application, you want to connect to someone, it is somehow using the socket deep down. Even if you are connecting to some server and downloading some file, for example, you are downloading a song inside your application. At that moment, it is creating a socket to that server sitting there waiting for incoming request to some file. And then it just reads the bytes of the file and just passes you through this connection. So I think this is enough for this session. Next session, we will start writing the client application, but not an Android application yet. You know, at some point we will also learn how to write the Android application version of the customer application. But for now, we will just only, this is the shop manager application. The user of this application is the manager. We will write another application here for the customer, which will be again also a console application. You know, it will get the orders here, and then it will send it to this. And after we advance and we build some server, you know, server stuff, then we will move to some kind of a real desktop or a real UI, user interface application. Okay, I think this is enough for this session.
That was interesting. Thank you.
Okay, you don't have any question?
No.
I know it was a lot, but it will be fun, I assure you. Okay.